My name is Rachel Martino, and I'm a principal consultant with Pragmatic Works. And as a consultant with Pragmatic Works, I have been using Power BI in some projects. One of the things I've noticed is that performance can be an issue if you're not careful. I myself am a SQL Server and Oracle developer from a long time back. I've been an IT manager and a consultant, and I've worked with the Microsoft SQL Server and development tools and BI tool stack for many years. I'm focused on BI and really interested in working with companies on building a culture of excellence around the management and use of data within their organizations. I live in the Boston area, so I'm local to the Northeast, although today I happen to be traveling in upstate New York. And for a little something personal, I'm a big Ravelry fan and an avid knitter. The picture to the right is myself and my family. I'm the short one, and we're actually up in the Eiffel Tower recently. It was a great trip. I want to talk about performance in Power BI, not because it's a common issue, but because when it happens, we can be almost taken off balance a bit because we sort of expect Power BI, because it does such a fantastic job of managing our data and mashing different data sources together, we kind of expect it to be able to do anything. And so we pointed at data sets sometimes without really considering what's in the data set or what we might be pulling into our data model that might affect the ability of the data set to work properly. It is fast. It shares the core engine with the Power Query, Power Pivot, and Power View tools from Excel. And the in-memory columnar data storage is really what makes tabular model in SSAS so powerful. So the X-Velocity in-memory analytics engine provides us with a number of optimizations to the way our data is handled and prepared for us and stored that make this a very powerful platform capable of handling large amounts of information and very nimbly returning the right information to us. X-Velocity is the analytics engine that is shared by the tools I listed before, the Excel Power Tools, the Power BI, and SSAS Tabular. And some of the aspects of that engine that make it so very powerful are the columnar storage, which takes your table with many columns within for each row, and instead of storing the row information all together, it splits out the column information and stores that separately. By doing that, it is able to compress those columns down to unique values, or even use some advanced compression algorithms if the values are predictably modified within the column, and in that way have a very highly efficient capability for searching and returning values from the columns. In BI, we typically don't return many columns from a table at one time, so being able to get all of the columns associated with a given row is not necessarily the most efficient way to query. We might be better off pulling just the columns that we're asking for, and that's what columnar storage takes advantage of. All of this storage is cached into memory while you're using your data set, and that combined with the compression and the columnar storage makes this a very powerful way to search and find information through your data. However, for the user experience, the time that we have to provide the user who is consuming our data tools, or even ourselves as we're doing discovery against our data sets, is a very short amount of time. There's a popular theory that now is 3 seconds. That if I click on something and I don't get a response within 3 seconds, I feel as if I have waited for it. And that is our operational target when we're working in these, to build these user interfaces that will enable people to analyze their information. Or like I said before, even when we're trying to use these tools for discovery of information. Because one of the great features of this environment is the ability to pull together a number of data sets, link them up very quickly, and see how they affect each other. Performance impacts can start to show up during data load. It can show up during design, and also, the worst case for our users is in the visualization layer, slow slicers, slow reports loading, and things like that. During data load, we can see, first of all, that it takes just a long time to pull all of the data from the server or from the data source, or that once it is finally all pulled over, it may take a long time to load that into memory or into storage because of inefficiency in our information. During design, in my particular case where I was working with some tables that I'm going to demonstrate, I noticed during design that as I created new calculated columns within my tables, those were taking a very long time to complete the calculations and save them back to the table for each calculation that I make. Also, you can notice when you're starting to have performance issues that relationships and the management of relationships can take a long time. There's a few thumbnail indicators. If you start to feel like things are getting slow, one of the ways that I identified this problem, sort of a first cut, if you will, at is this a real problem or am I just experiencing something different, is to take a look at your saved file size. This is also a great way to see how you're doing with optimization. It's not as meaningful as the size of the data after it's loaded into memory, but I'm going to show you a way to see that as well in a little bit. But saved file size example is here on the screen where the top row that's highlighted represents the data model that I was working with when I realized I had a real problem. And you can see that it was over half a gig. So I started optimizing that data model, and in the next step I got it down to 46 megs. So there's a huge decrease in the size, and that's 8%, I think, of the original size. Then I added some data back and needed to expand the data model, but ultimately, even with the expanded data model, along with the optimizations I put in place on one data set, I was able to get my size down for my finished PBX file to 44 meg, which was a huge improvement in the storage size of the file and my ability to move the file around, but what it really meant was that there was a huge improvement in the amount of data that was in memory and the way it was stored and the performance of the solution itself, both in data load and processing and in user experience as well. So I want to show you what I'm talking about here for a second. And, you know, I've mentioned before, Power BI is a very powerful tool. And therefore, I had to load quite a bit of data in to start to experience this problem again, and especially on the user end, because the data loads can be slow, and I will demonstrate that, that takes a little while to demonstrate. But the user experience is really where we determine the overall value of our solution. And in this case, what I'm showing you is within Power BI Desktop, I have loaded up a number of data sets, which are listed out over to the right. And they are data sets from the Salesforce environment of a client. And the information, I have tried to obfuscate that information so that we don't really see anything that's identifying here. However, I've left the amount of information that we were pulling, and just to give you a quick idea, it's not a huge amount of data, but if we count up the tables, and you can see already we're having some performance issues. There are 652 sales, 16,000 or more accounts, 34,000 or more opportunities, and the biggie, the star of our show today is the task table, which has 382,570 some odd kilobyte thousand rows. So task is a decent sized table. 380,000 rows is not something that we would dismiss from Power BI or think that Power BI couldn't handle it. But really with task, it's about the number of columns, and more than even the number of columns, the type of columns. And I'm going to spend some time showing you how we can identify which of these columns are the ones that are causing our problems and how to avoid loading those or how to fix them if that's the case. Just to give you another idea of how the timing can affect the user experience, if I start using these slicers, and I have many slicers on this page, slicing this data set, they have to update each other and the data set. And that means scanning quite a bit of data in order to load the content. So with each selection that I make, there's a user experience of wait time before the solution is returned. Now I want to show you another example, so I'm going to close this out and I'm going to open a new Power BI solution, and in that solution I'm going to load our task data that we're going to use today, and I want you to see what the load process is like. It's taking a moment to load Power BI. So when we go to load the data, I'm going to use get data from SQL Server. I'm going to grab this query that I have here. This is all of the columns that are on the task table. I have loaded the task information into a staging database for simplicity here so that I don't need to rely on connection to Salesforce. So we're just running from a local SQL server. And this is not SSAS tabular. We're using Power BI as our data model storage. Our database is reporting. And let's go ahead and enter our SQL statement. And I have, oh, we can shut that off. I have a little timer that I'm going to use to time our experience. I'm going to start by editing this. It's going to load the preview into the query editor. So just take a moment. And basically, I'm going to name this our task table. And now I'm going to start our timer and hit close and apply. So let's pull our timer back up. And right now, the Power BI solution is returning to our SQL database and starting to pull our rows from the task table. And you can see that it's pulling them in kind of smallish chunks because there's a lot of data in each row. It's also going to take a while to get to 382,577 rows. And this is the first inkling that you might have that you're going to have a performance problem with your data. I'm going to leave this running for a moment, and I'm going to show you what I did once I noticed that it was taking a very long time. I took the stage table create script and I just parsed it out in Excel. And I'm not saying you have to do this. I really did this for my own information. And I took a look at the various data types that were in there, and I could see that there were quite a few data elements that were nvarchar or string effectively, and some of them were very, very large. This one was actually much larger than 255. And so you could get a good idea about how much data is being loaded, even with only almost 400,000 rows loading into our environment. So we're getting close now, and we're a minute, we'll probably be about 2 minutes in, there we go, when we hit our last row. And now we're not done. So we've pulled the data in, but it's time to organize it, store it, compress it, and do all of that overhead that needs to be done when you're loading new data. So having too much data in your data set that you're loading can affect your data load process profoundly, and it may not seem like a large price to pay, but in fact, this is something that's going, as you use your data as your solution as a source, and you're repeatedly refreshing your data, you're going through this process with every data refresh. And it's a very expensive process, and it takes quite a bit of time. And if you have calculations on those tables, then the calculations have to be executed as well. So at a little over 3 minutes, we should find that this data has been completely loaded. We're getting close. And the information then is available to us in Power BI, but some of those fields that we have pulled, if we take a look at them, they're not fields that we're likely to be using in an analysis. Let's go back. This is going to take its good sweet time. Let's go back and think about some of the fields we have here. Recurrence by activity ID may or may not be something that we report on, but if we're reporting on recurrence, then we could get rid of all of these fields. If we're not recording on some of the call, we're not reporting on some of the call recording fields, then there's no reason to even bring those in. And bringing those in, we've shown, is an expensive operation. I distracted us from that data load. But here's our task table. And again, you can see that we have quite a few fields, and they are available to us for reporting, but at what cost? So how do we solve these problems? The number one tip out there for working with columnar in-memory data storage is that, with some caveats, tall, narrow tables are faster. So you want to enable your columnar storage to compress your columns, to be able to compress your columns, and you want to compress and store the minimum number of columns necessary. If you have any fields in your data set that you're not using, remove those. There's no reason for them. They're adding overhead to your data loads. They're adding overhead to your storage, and they're not helping you. Remove any relationship IDs that are not in use. They are fields that probably are very unique. In other words, there's a lot of values, different values in that column on different rows, so that unless the relationship is a grouping of some kind, they may have what we call high cardinality and be a very unique column with many unique values. And particularly in the case of our Salesforce data, and I'm just going to pop back over to Excel again, the IDs to other data sets are varchars, which are string storage, and we're going to talk about that in a minute. So absolutely remove any fields that you're not using for analysis, and make sure that you are enabling your data set to store the fewest number of columns possible, even if that means having more rows in most cases. In other words, you might find yourself with a table where you have a product on a row and then monthly sales values going across. That might be something that you're better off unpivoting and making into a long table of products, months, and a single value, and those being the only 3 columns in each of your rows. Even though that will multiply the number of rows, it will minimize the number of columns, which is the focus of the storage in this engine. Now, I do have the exception listed at the bottom of the page, and I have a number of links sprinkled throughout this presentation so that when you have access to the presentation, you'll be able to follow those and read the sources. Certainly, I found a lot of great information out there on the internet. One of the key pieces of information is that there might be a situation where you have so many millions of rows that having more rows in 1 million row chunks of columns, which is how the columnar storage works, actually causes more trouble than having more columns. So once you get to very large data sets with many, many rows, you'll want to go back and take a look at that reference and see if you're at a trade-off point. This is probably our primary tip, and it seems obvious, but when we're just mashing up data, especially to do discovery, we can pull in information that we really don't need. Integers are faster than strings. Strings are stored in a hash table in the Xvelocity engine, and the access of the string value from the hash table causes some overhead that can make them slower than other data types like bits or integers. So you'll want to be aware of using strings, especially strings as IDs. When strings are IDs on tables, now you have a highly unique column with a high cardinality that is string storage. And that is a big memory trap, and also can cause slowness if you're using that for reference. My plan here, just to let you know, I realize I'm giving you a lot of slides up front. I'm going through the tips first, and then I'm going to go back and do some exercises against our data set and show you how we get those file sizes down and how we can look at the memory size. Slicers use multiple queries. In our visualization layer, our objective is to give our user the most immediate experience, the 3 seconds of now when they click on a slicer, and what we don't want is for them to watch that loading line going across the screen or the spinning icon while they're waiting for the effect of a slicer. But slicers can be somewhat problematic if you're not careful. Slicers issue two queries. The first is to reference the list to make sure that it's got the value that you selected, and the second is to query and find out which rows of the pivot tables are affected. So although it seems like it would be a one query activity, I'm sending this value to that pivot table, in fact it has to do a reference against the value that you clicked and find out what that is and then apply it to the pivot table. So it can be a slower activity than you might think. And when you cross-filter them against each other, those same two queries have to be executed all across all of your slicers. So in that example where I had, I don't know, 6 or 8 slicers on the page, they were affecting each other's performance. And if you use high cardinality fields in your slicers, in other words, if you use fields that have many, many unique values, this can be a problem for performance, but also a problem for usability. A slicer with many, many rows in it is less usable for someone who's doing some analysis than a slicer with a few rows that cuts down and shows the effect of how many rows are left. So you want to be careful of using very descriptive fields or IDs or unique values in your slicers unless you've been able to provide a mechanism for a hierarchy of chunking those into smaller pieces. And that's a usability concern. And as far as performance goes, we go back to each one of those clicks is 2 queries, and if one of those queries is against a large data set, it's going to be slower. You want to make sure when you're creating columns and when you're creating measures that you understand what the effect of your DAX functions may be. As you add more calculated columns to your data model, the DAX engine will have to compile those and calculate those values each time your data is refreshed or each time it is loaded. And after that, those are static values. But while that's happening, that can be an expensive operation. If you've used a lot of filters, filters don't have the ability to do bulk scans of your data set. So if you're filtering large data sets, that can be an expensive operation. Min is another example of a command that can be an expensive command. So I have 2 more tips, and I want to talk about some techniques, and then I'm going to demonstrate some of this for you. It can be extremely helpful to make sure that your calendar, which is a daily list of date information and metadata about dates, if you have a lot of dates in there that are not part of your reporting data set, those are overhead to your queries, and a slicer or a filter operation will have to go through all of those extra rows and make sure that they're not part of your query. So if you have a Power BI data set that you're putting together, a data model, pull that calendar back and only include in it dates that you're going to be using for reporting. And the last item, it can be a little tricky to describe. The uniqueness of the column can cause challenges for compression and columnar storage. And therefore, it may be more efficient to take your column and make it less unique. A great example of this is a date time value. If you have in your data set, let's say, the dates and times that tasks were created in the task database, it may not be that important to know what time every day, but we might be reporting on what day. Well then, when we put that data into our data set, let's get rid of the time information. The reason is that if you have a date and time in that value, every day there are thousands of entries if you think about it being hours, minutes, and seconds, and fractions of seconds. There could be many hundreds of tasks created in a day. Each one was probably very likely to have been created at a different time. That columnar storage on that date time field is going to have a lot of trouble compressing all of those values down if they're all unique. But if you truncate off the time and keep only the date, then it can compress all of those that were created that one day into a single date entry. Much more efficient storage. So watch your granularity. If it's important to keep the time value, find out what level of time value is important and keep down to that, and put it in a separate table so that, excuse me, not a separate table, put it in a separate column so that it too can be compressed effectively. One way to understand some of the issues with calculations is that the formula engine for Power BI is very I/O intensive. Unlike the in-memory data storage and reference, it is I/O intensive and it runs on a single thread. So calculations can cause real performance issues during data loads and processing. This is something that you're going to want to consider when you're creating your data set. If you're going to be refreshing it on a regular basis, it might be much more efficient and effective to have the calculations performed on the database side or the data source side if that's possible. In the case of SQL Server or some other data sources, they have very powerful calculation engines themselves that can much more effectively handle those calculations and return back a data set. Once those are created in your data set within Power BI, however, those are static values and you don't need to worry about that being recalculated. But measures are calculated during query execution. In other words, because a measure may be affected by how much information was included in the last query, that is constantly being recalculated. Calculations, however, are fixed as of the time of data load and referenced as such. One thing that I really noticed when I started having this problem with my data model was that it was on calculations. When I was creating my 12th and 13th calculation in my data model, I found that the calculations were getting slower and slower to be created. And some research showed me that every change in the data model requires a recalc of all calculated columns. And that turned out to be very expensive activity for me. Shifting a lot of those calculations back to the database made a huge difference. So that's 7 tips. I went through them pretty quickly, but I want to get to demonstration. I want to show you one technique first because I think that this is a very powerful tool that will help you to better understand when you're having a memory problem, what the impact of that problem is on your data set. Although I showed you the saved file size of my solutions where I identified performance issues, a better way of knowing what the performance impact is to look at the memory usage of each table and field in your data model using Casper de Jong's, and I'm not sure I'm pronouncing that correctly, Power Pivot memory usage tool in Excel. So let's take a look at that. I do have one more reference for you, and that is to DAX Studio. not going to have time to show you DAX Studio today. I don't use that tool very effectively myself. It's one of the things I want to learn. So if someone has some great references for that, I would love to see them. But it is a great way to review your DAX and see what the query plan is for your DAX and understand what the impact of a given statement may be for your data set. So let's see if this gets any better. So we have loaded in our Power BI desktop the task table. What we know about that table is that if we look at the operating system, if we look at the file viewer, we can see that task only data, this row 0 here, is actually over half a gig in size when I save it locally. But let's go to Excel and let's see. I want to get rid of this. And let's see what the impact is of that on the memory of the system. So in Power Pivot, I can show you here that I have loaded my task data, all of the columns in that table, just as we loaded into Power BI. I have loaded those here into this data set in Excel. Now I realize that Excel and Power BI are two different tools. However, the scripting language in Excel has enabled Casper de Jong to create this macro called get memory usage that when we run it against a loaded data set provides us with the table, the field names and data types, and the memory size that's being used in memory for storage of that value. So if I sort this table largest to smallest, I see that the description field is a string field, but it is storing almost a gigabyte in memory. This pivot table over to the right gives me a graphical representation of that, and I can see description is by far my biggest field. However, the Synity call recording field is pretty serious as well. ID is another significantly large file, and in fact, what I want to point out is that of the top 5 fields, we can highlight them over here to see what I'm saying. They're all strings. We talked about the inefficiency of storing strings, especially those with a high cardinality or many, many unique fields. So let's see what happens if we get rid of those. I'm going to delete my task table from this Power BI desktop. It's the only thing in here, so now my data model is empty. And I'm going to get data from SQL Server. I'm going to go back to my same database and the same table, in fact, but this time I'm going to use a slightly different query. And all I have done in that query is remove the string values that were identified as highly memory intensive. Now, this one has not been removed, so I'm going to grab that one too. I think that was the third one, Synity Recording C. So we'll grab that one too, and we'll take the whole query. I ignored ID for a moment because I'm going to show you a better way to deal with ID than just taking it out, because we want to keep our unique identifier for our tasks. So here is our task query, and I'm going to set this to running. And when it runs, I'm just going to load it. I'm not going to go through the exercise of changing the table name. And when I hit OK and say it's going to import it, I'm also going to kick off my timer. So before it took 3 minutes to load. Now already we can see that we're grabbing bigger chunks of data with each block of information that is pulled over, and it's moving considerably faster through the data set. There are still the same number of rows because I didn't actually cut down on any data that was being pulled in except to remove columns that were highly descriptive that I wasn't going to report against anyway. So already we've reached the end of loading our entire data set, and now it's processing that and loading it into the columnar data store and into in-memory storage. Already it's moved on to detecting relationships. Table. So this is about 30% of the amount of time it took to load the entire data set. All we've done is remove those top four fields really, because we ignored ID for now. So let's go back and let's see. Let's create a new Excel spreadsheet, and let's find out how much memory that's using. So, excuse me. It's a new query from SQL Server. And paste in the same query. Load the data here. It will take a few moments to load, just as it did in Power BI. Once it's loaded, though, we can take a look at how much in-memory storage it occupies. So there you go. You can see here this is faster to the preview. I'm going to hit close and load, and I'm just going to tell it to close and load to the data model, not to a table in the spreadsheet. So that'll start loading. Again, much larger chunks of data coming in, much faster data load process for having removed those large fields. But this is going to enable us to determine what our next optimization is. So now it's loading the information up into the data model, into memory. You can see that at the bottom where it says retrieving data. A little over halfway through that process now. And when we run the macro, we will see that the columns that are taking up the most memory will be a different set of columns, and those will be the ones we attack next. So we go to developer macros and run. Very quickly we get back the current table structure and memory size of each row, but let's take a look at the pivot table, and we can see that the ID field is now our biggest one because we got rid of the description field and the other field that were bigger. And now we're getting dates in our top group and IDs, and still some large string fields, but it's a little bit different set of information that's causing the problem. So in order to solve those issues, I made some changes to my query once more, and this time, and I'm actually going to start at the bottom and work my way up. This time I removed really any field I thought we were not going to be reporting on, which is kind of a matter of looking forward and figuring out what people will be doing in the future, because of course the objective is to provide a data set that people can do more sort of ad hoc and self-service capabilities against. But in truth, I don't think anyone will be searching against call recordings or recurrence intervals. So it's a judgment call. You take out what you can. I also tried to reduce the cardinality of the date tables, the date time tables, by changing them to date tables. And so I did that with all of the date time tables I could find. I took system mod stamp out because I didn't feel like that was a date time field that we needed at all if we had created date and last modified date. And for the ID, which previously was a 18-character varchar field, I changed it. I took out ID altogether. You can see it's commented out here, and I added a integer, effectively sequence or row number integer to each row. After sorting, at the bottom I've sorted by ID value, so that the rows will come out in the order of the ID, but the new ID will now be an integer value, because that varchar, I'm sorry, I'm looking at the wrong version. That varchar ID field was very expensive for us to store. So let's see what happens when we load this data. So we'll copy this query into Power BI. Let's see if we can delete some of these to maybe make things go a little faster. All right, we'll come back here. I'm going to delete this query, and we're going to run our new query to get data into Power BI. And hit the OK button. Pull this guy up and give it a little reset. Start that counting, and our data will load, connecting to the data source, and now we're moving very quickly through our data set and pulling it down from our server. And you can see there's a very noticeable difference in the performance of the data load. And now we're on to detecting relationships, and we're previewing the data 30 seconds. So by removing even more information, plus removing that string value that was our ID field, which is, of course, a completely unique value requiring columnar storage for every entry, we saved a lot of space in our memory. So let's see how much. We'll come back here to our Excel, and I will actually, let's do like we did with the other. Let's delete some of these so that we don't have quite so many running. We don't need that guy anymore. And let's create a new spreadsheet. And we're going to load our data from SQL Server into Excel. It would be very nice if we were able to point Excel to the Power BI data source, but we don't have that ability yet. Or if we do, I don't know about it, and I'd love to know. So as it is right now, we'll just keep repeating the data load on both. I could load the data into Excel and then pull it into Power BI, however. But since this is Power BI demo, I thought it was appropriate to start with Power BI. As you can see, we load the preview very quickly. And we're only loading into the data model, so now we're going to actually load the data. But we know this should take about half a second to completely, half a minute to completely load the data, given what it took in Power BI. And we're making, 60,000 record jumps ahead in loading the data into memory. So it's much, much faster process now that we've limited the number of columns. And that's that tip number one, tall, narrow, remove any data that you're not actively reporting on. So let's take a look at what the macro tells us. And we can see that now we've gone from over a gigabyte in memory to having 18 meg of memory occupied once we load all our data in for the task table, once we load the data that we need. And we can see as well an interesting phenomenon here in that the top, 8 or 9 rows represent ID fields. And we talked about including reference IDs to other tables if you are not going to be reporting on those other tables. And this shows you that those can be expensive as well. Not nearly as expensive as having our own table ID be string value, but still an expensive operation because we're storing a high cardinality value in our columnar data store, and in this case it also happens to be a string value, which doesn't compress like integers can. So I just want to point that out. I'm not going to fix that problem because that problem starts getting into, modifying, adding surrogate keys, but that's one of the benefits of adding surrogate keys in your data model. But that gets to be pretty intricate. I think that what we've shown is that we could take a table that at first seemed like it was just too big to use and reduce it down to a size where it was very usable. And I want to show you what we see when we pull the data source into Power BI. So this number 4 Power BI solution that I have here includes the reduced task table, and I also went into my date and removed some of the unused dates. So this is a Power BI solution that is the same report that you saw in the initial solution that I opened that was very slow to load and very slow to update. But now what you'll see is that with the extra dates removed and with the columns that we're not using for reporting anyway on the task table removed, it's a much more responsive file as soon as it loads. I have a lot of things open at this stage. It's an interesting deal. So now it's loading up the visualizations, and task table now has a lower values, and we can see that although we still have a great number of slicers and they affect each other, the behavior of the site is better. It loads faster, it works better, and the responsiveness to the user is even improved somewhat. In this case, a lot of the improvements we've aimed at are focused on the data load process. But the first thing I would do in this case is I would wonder if we needed all these slicers on this page. But you can see from the counts page that we're still working with the same number of rows. We haven't changed the number of rows, we've only changed the amount of data in the data set. So in conclusion, I just want to reiterate, Power BI is a fast tool. It is very good for pointing at your data source, loading it up, and doing discovery on and investigation. But if what you find when you're investigating is that you are getting performance issues, then when you think about making a repeatable process or making a solution that you're going to use again and again or publish, then you want to be aware of some tricks you can take, tips, tricks and techniques to make sure that you're delivering a streamlined data set. Large is relative in this case. We didn't have that big a table. It was only 382,000 rows, but the size of the columns, it wasn't even that many columns. It was the size of the columns and the lack of efficiency in the data that was loaded in the columns that was causing us trouble. So when you are working with Power BI and you're producing something that may be reused by someone else, think about your data model and your calculations and how they might be affecting the performance of your Power BI. There's some more references here. I found a great wealth of information on how to use this tool and how to make it operate better. I know that we have 5 minutes left, I think, in our time, Liz, and I would like to open up for questions if people have them.
Yep. Does the work that happens when a slicer is used happen client-side?
It depends. If you're using desktop, yes. But if you're using Power BI published, that's happening up on the published Power BI solution in the cloud.
Okay. When creating dimension tables and updating the, I don't know what that says, ID in Power, okay, I'm going to skip that one. I'll send it to you afterwards.
Okay.
If you discourage slicers, what's your recommendation?
Oh, I do not discourage slicers. Oh, well, let me rephrase. Slicers are a great tool, and if you need to slice on a particular column that has a high cardinality in it, then that's an excellent time to use cross-filtering of slicers and set up a slicer hierarchy, if you will, so that you can filter by groups of slicers, so that first you're saying, I want only the Northeast projects, and then I want only those that were done within Massachusetts, and then I want only those that were within this zip code, and now pick from your selection of projects. Having one long slicer list of all your project numbers would be a difficult to navigate list for your user. And slicers in and of themselves aren't necessarily a performance problem, but if you're seeing a performance problem in your user interface, you will want to look to those cross-filtered slicers and see if you have a situation where, like on mine, where you have one slicer that's a long list of IDs and then another slicer that's a long list of another set of IDs, and just really very query-intensive slicers that are going to start affecting each other when you select one or the other. You just want to use them with caution.
Okay. For date fields, is it better from a performance perspective to format the date in SQL prior to bringing it into Power Pivot?
You could do that, and I haven't really experimented with particularly formatting it in a certain way in the SQL side, but I did demonstrate that if we change it to a date as opposed to a date time, that improves the response. That would be an interesting experiment of converting it to a string value that represents the date.
Okay. This is a question we get asked a lot. Do you know when Power BI Desktop Client will be able to publish on-site versus PowerBI.com?
Could you say the first part again? I'm sorry.
Yes, they just want to know when the Power BI Desktop will be able to publish on-site versus PowerBI.com.
Oh, yes, yeah, we all want to know that. I don't have that information, but keep your eyes out on the Power BI sites for further information about that. However, I will say that there are some other reporting tools that do enable building dashboards that are on-premises solutions. But yes, I do see the value and the need for that.
Okay. Could you share the macro to calculate the size of our data? It's a really nice tool.
It is a really nice tool. I want to make sure I'm not taking credit for it. I found it online. It's Casper de Jong's macro, and let me see if I can get us back to it. Let's just flip back through the slides. Here we go. And what I want to emphasize is that I will make these slides available, and every page has a reference in it so that you can get back to the best or some of the most descriptive information I could find about that particular topic, including a reference to where you can get to his memory usage tool.
Okay, great. We are out of time. I know there are several questions that we did not get to, so I'll make sure to send them to Rachel. She is going to post her slides and everything, as well as hopefully these questions in a blog on our blog site. So stay tuned. Make sure you're following us on Twitter and social media to keep an eye out for that. This session is recorded as always, so you will get a link to the recording tomorrow. If you have any other questions, please feel free to email me, Liz. It's the email that comes with all your GoToWebinar information, and I'll be happy to pass those along to Rachel. Rachel, thank you so much for the session today, and thank you everybody for joining us.
Thanks, everybody.
Thanks, Rachel.
Bye-bye now.